Hello, this is a quick update on GoKB 6.0 development relating to the batch load process that we've been working on. So this is adjusting the focus from a refine oriented process to a more batch oriented process so that we can handle bigger chunks of data from a more diverse set of sources. Kristen has asked me to just make a quick screencast so that anybody not on the calls can get an idea of where we're up to. What I'm going to do then is I've got an empty GoKB here, which is not the usual state of affairs, but it's useful for letting us test the performance of the data load, because obviously in normal operation we've loaded the NCSU name authority file, so we don't have to create new organizations, we don't have to create lots of new title data. So starting with an empty GoKB lets us test in some ways the worst case in terms of the amount of work we have to do. Of course, the flip side is doing title matching is very different on a database of 600 titles than 600 million titles. But that latter case is more about optimizing the data structure and the indexes, so that's something we can address in different ways. So this just gives us a really nice baseline in terms of getting an idea and a feel for performance. What we've got is we've been working with a number of different data sources, and particularly we started working with the CUFTS data. So that's the one I'm going to do a test on, because I've got a reasonably sized file that won't take too long in terms of this demo. And I've got a file in particular, the Muse all titles file, which has some problems that GoKB would normally pick up. And we'd like an administrator or an editor to go over those problems and figure out what to do about them. The other thing about this process is normally when you get updates from places like EBSCO or CUFTS, they'll be coming in terms of an FTP upload, or we'll be downloading them from a site. So it's not that we want a user to have to manually go to a website and upload a file. That's just ridiculous and not really scalable. So we're trying to script a process whereby we can automate fetching changed files and injecting them. So what I've got here is a script which just injects a few files from CUFTS, and I'm going to pick on this one in particular. And this is demonstrating, we're using the command line so that we can show how we'd be able to pipeline processes together and run them in the background without user intervention. So you can imagine that what I'm about to do by hand would normally be done by some overnight process that was running at midnight, for example. I'll just quickly go over this. So curl is a command for basically talking to web services from the command line. Locally, I don't really have a secure, I just have admin as my username and password. The content parameter, so that's the file we're actually going to load, and you can see it's in a subdirectory called load problems, and then we've got the Muse all titles file there. We have a source identifier, so this is saying this is the authoritative source for this data, and we're saying in this case it's CUFT, so obviously for EBSCO it would be EBSCO data. We define a particular format, so this tells us what columns we can expect and what kinds of checks and transformations we might need to do on data from a particular source. So these two things together tell us how we should interpret files, and generally speaking all the files from CUFTS will have these two things set the same. We can set them differently if we have exceptions or special edge cases, but normally they'll be set to the same. We might say the CUFTS format and then have a different source if we wanted to treat other files from CUFTS differently. So we could have said CUFTS Muse here if we wanted to be more specific, but actually it's not necessary, it turns out. The package parameter gives us the package name, so when we load this into GoKB the first time and subsequent times, we'll be working on a project called Project Muse all titles, and that's used so that we can figure out what we're updating later on as well as create it initially. Platform URL is the default platform URL we'll be creating. Format tells us we'd like the system to give us a JSON response, so this is where we're doing system-to-system integration, or we're scripting some workflow engine that will look in a directory and then upload the files for us, for example. So this is about the kind of systems mechanics layer, and I'm just saying please give me a JSON response which will let me know whether things went okay or not, rather than trying to render a HTML page, which is what a user would normally do. Provider name is the the provider of the file basically, so we're saying Project Muse in this case. Provider identifier namespace is basically telling us how to handle the title ID field. So the problem is that when you're uploading lots of files from lots of different providers, they all use title ID as a standard, which says my particular provider ID is X. But of course, it's possible to get namespace clashes because Project Muse might have a title ID of 1, or CUFTS might have a title ID of 1. EBSCO might also have a title ID of 1, and they're clearly not the same title. So this setting lets us say, whenever you encounter a title ID, please put it into this particular namespace. So we're just using Project Muse here. We could use CUFTS actually, but it doesn't really matter. The reprocess flag says, even though you might have seen this file before, which we won't have in this case because it's an empty database, I'd like you to reprocess it, please. So it's a way of forcing processing on a file. Synchronous says, please wait until you finish processing the file to exit from this curl command. We can set this to no and just inject, hundreds of files into the system. But actually for batch processors, it's more sensible in terms of controlling the load on the servers to actually process them in series. If we wanted to have a few running at a time, we could set the thread pool size. So for example, we would churn through 5 files at a time. But this, again, is just a way of me controlling throughput so that I can get a more accurate idea about how long performance is taking. And then finally flags, and this is a way that we're experimenting with to allow the administrator on a per case basis to switch off specific actions and checks and review requests. So the default actually is that everything is switched on, but they're here really as documentation more than anything else. I'm saying for all those cases where you might create review requests on new titles, please do so, and variant names, and please review new organizations as well. And then finally, the last thing we do is to actually give it the address of the service we want to talk to. So this is on localhost because I'm running on my local development machine. It's not an overly powerful machine. It's certainly not server scale. And this is the path, obviously. So what I'll do is I'll run this by hand. So if I just set the GoKB host to be localhost, and then I'm going to copy this curl command. And this, as I say, this is what a system would normally do. I suppose I should let you have a quick look at the Muse all titles file before I do it. So that's the file that we're about to load, and it is, I think it's about 600 titles. 647 titles are in that file. So that's what we're going to load. Let me grab my curl command. Right, so I'm just going to run that now. And basically what this is doing is processing the file. And if I switch over to my background, my debugging, you'll see that it's basically busy working through the file. While it's just doing that, I'll very quickly explain the process. So very poor diagram, I apologize. What we've got are a set of rules, and obviously on the first ingest we don't have any rules, and we have a data file. It goes through this first phase of the processing, which is running now, probably completed, and we have a set of pre-flight checks. The result of that pre-flight is either a pass or a fail. And if it's a fail, what we'll have are some review requests raised. The review requests, so this process might run at midnight, and then at 9 o'clock the next morning, Kristen might come into the office and say, can you tell me what's gone wrong overnight? You look at the review requests, and a result of that processing is some changes to the rules that might be ingested. A user can then trigger a re-ingest of the file, or what you might do, of course, is just wait for the batch processing the next night to see if the file has changed and re-ingest it. The second time through, we'll have some better rules. So the data file will come in, the rules will be applied, and then we either will or we won't pass pre-flight. If we don't pass pre-flight, we go around this loop again. If we do pass pre-flight, then we go into a processing phase. The thing which is different between this process and the refine process, of course, is that in refine, ultimately you're changing the input file. as a result of your process. With this process, what we're doing is changing the rules that we know about how to handle error cases in the data file. So it's subtly different. What we're not doing with this process really is changing the data file. What we are doing is building up a knowledge base of exceptions and how to handle them in the data file. So it's subtly different. And of course, the useful thing about that is the rules themselves then become a reusable part of the knowledge base. And we, in theory at least, we could share those rule sets amongst different people who process these files. And so we're really building up an errata of provider data sets rather than a fixed set of data sets. And we're learning how to handle the error cases. So that's the revised process, if you like. This is me just switching back, so you can see my curl command has completed, and if I'm just looking at my debugging, because obviously this all happens in the background, there's no particular user interface for this, you'll see that we've got this final message which says we got a job result, and the event was that it failed the pre-flight checks. We've also got a message saying we should review request 1, and a message saying the ingest completed after basically 27 seconds, 27,000 milliseconds. So what we do then is, if we have a quick look at GoKB, if I go to search request for review, and we can see that we now have this one review request, and the cause is ingest of data file 5, project moves, all titles failed pre-flight. And if I go in there, I get this information as part of the review request. And what it's doing is it's saying these are the problems that I encountered trying to load that data file. We need to do a little bit of tidying up on the formatting and make this a bit more human readable. But in actual fact, there are 1, 2, 3, 4, 5 error cases here, and they're all the same, actually, all inconsistent title identifier exceptions. And if I just read to you the text, so we can extend the cases that we can detect with this. It's pretty configurable, it's pretty extensible in terms of what we can plug in for detecting new error cases and giving options that you can take on the basis of those cases. I'll just read this to you because it's not perhaps easy to read. What it says is that new title modern drama matched via its identifiers, and then we have the ISSN and the EISSN, against a title with the internal ID of 1249, but that title string is modern drama, world drama from 1850 to the present. Then there's a bit of explanation that explains why often when we're loading data files, different titles with the same identifiers are an indicator of problems with the title history. So if a publisher didn't know the previous identifier, they might have used the previous title but the current identifier, for example. And so the result of this error message is that we have to make a choice. And again, this is an extensible list, but these are the 2 options that we have at the moment. We can say, you know what, the reason that it's actually different is that it really is a different title. So what I want you to do is to create a new title and add it as a preceding title, and then we can optionally give it a date, or we can add it as a proceeding title, as a following title, and we can say the date that this happened on is this. It won't be created with ISSN or EISSN, but it will be created as a title and linked in the title history. And the next time the system sees that case, it'll understand, pardon me, what has gone wrong, and it won't prompt for this particular problem because it'll learn how to deal with it. And actually, because we've created a title in the title history, this case won't even occur in its first form. The other option is we can say, you know what, actually it's just that somebody's been really lazy, and modern drama is really the same title as modern drama, world drama from 1850 to the present. And that's what I'm going to decide. I'm going to say, you know what, it actually turns out that we've got the same title in there twice. And what I'm going to do is, for the sake of brevity, I'm going to assume that that's the case for this 5 occurrences. Pretty fair, actually. So the bottom one, for example, newsletter, the Historians Film Committee, and the title that I encountered later on was Film and History, an Interdisciplinary Journal. So it's actually probably a little bit, that probably is a different title. So you'd want to do something else, create a new title. And I think we'll talk with the GoKB domain experts about what the right options are to offer for these different cases. I'm going to leave this as it is for now. I'm going to say that really is a variant of this one. So add update selected rules, this button, takes us back around. So these are still here. We can change our choices. We can change the rules, the responses that we're setting. And if I wanted to, I could trigger a reprocessing of this file here, but that seems a little bit unwise because of course you don't know what other files might have been processed in between. So all we've really done, sorry, all over the place, is we've been through this once. We've loaded a data file, it's failed pre-flight, we've got a review request, and we've changed some rules. What I can do then is I can go back to my command line, and this is the equivalent again of a system agent overnight. It's detected that this CUFTS file has changed, and it's going to submit it back to GoKB. So that's what I've done. I've picked up, as it happens, the same file, but because reprocesses yes, I'm going to re-ingest it now. And we can have a quick look at this in the background. We can see it's busily working through all these titles. I could tell you actually now, just from the log files, that it has passed pre-flight this time, so it's actually processing the file this time. Just be patient. As I said, my machine's not especially powerful, so it's a good deal slower than a proper server would be. And of course I've got the database and the web application and everything else running on one host, so there's no horizontal scaling going on. Okay, so that's finished. So we've got this time a slightly different message, event processing complete. We've got a message saying that we've actually processed 646 rows. Average time taken per row is 80 milliseconds, which means that the average processing speed for this case is about 45,000 per hour, which isn't bad going. But as I said, the important thing is that this is a very edge case because we're creating all the new data. So if I go back to the application, here we are. If I search my packages now, you'll see that I've now got a project moves file. We've got 637 titles. The reason for the discrepancy is that obviously some rows were duplicate rows because we decided to add titles as variant names rather than as actual names. So if I have a quick look at the titles there, you'll see we've got project moves titles. What I'll do is if I go into titles, sorry, let me go back to review requests and look at that one again. Or you can see the review requests for new organizations and titles that have been created. So actually there's quite a lot of work in ingesting this file the first time in terms of creating publishers and providers and platform records that you wouldn't normally have to do. So what did we have first? Modern drama. So let's just go and take a quick look at modern drama titles. Modern drama. Okay, so what you can see is because we said modern drama is actually a variant name for this title, we've only got the one record, modern drama. We'll go in there, and if we look in alternate names, we can see modern dramas there as an alternate name, which means this case now won't ever appear again when we try and load this data file in future, because we'll know that when we encounter modern drama with this particular set of identifiers, that it actually relates to this title properly. So that's quite handy. You can see that we've added the alternate title ID for this variant name here. If we'd made different choices, we might have created a different title. If we'd created a different title, it would only have this identifier. It wouldn't have these two ISSNs as identifiers. So that's the way that we would start to unpick this as a situation. And obviously, this, if we'd taken the other option of doing title history, then we'd see this now in the title history, and that's how the system would figure out what had gone on here. So the last thing that I should do, I think, is we've loaded this file, and as I said, so we're working on a basis of about 45,000 per hour, I think it was. I can't see it now. It's gone somewhere. Anyway, so that's when we're creating the publishers. So basically populating an empty system, 45,000 an hour. But having processed the file, of course, we now don't need to do any of that work. So tomorrow, when we load this file again, and it might have 1 or 2 lines changed in it. Probably it's got no lines changed in it actually. So what I'm going to do is I'm going to push the file through again now to see what sort of performance we get when we've already loaded the data. So this is a much more usual case, and you can see that it's taken 20 seconds, an average of 22 milliseconds per row, and when you crunch the numbers on that, it indicates to us that the average processing speed for GoKB should be about 163,000 titles an hour, which I think is pretty reasonable throughput actually. Again, on a reasonably sized server, we can run many of these processes in parallel, so there should be no real problem with scaling this up now. And I think actually we've not switched off review requests, we've not switched off a lot of the optional processing, which for certain providers like EBSCO, for example, we probably are happy to switch off org testing, because the odds are that you've already got lots of reference data for organizations. So we could actually eke out quite a bit more performance than this, but 22 milliseconds a row, not particularly bad performance, and it should allow us to scale things up quite reasonably. So that's where we're at with the batch loading process now, and that can just run in the background. We could run that for all the EBSCO titles, all the Project Muse titles, all the CUFTS titles rather, and just do that from a script, so there'd be no user involvement. The user involvement would come with the review requests and going in and saying, right, here are the edge cases. This is what I want you to do when you encounter this kind of a situation in the future, saving it for each of the different providers. And I should say, these rules are not stored at the level of the file. These are provider rules. So here we're making a rule base for CUFTS actually, but we could make it at the level of Muse. So similarly, we might have an EBSCO set of rules, and then whenever the same situation occurs in a file from that provider, we'll know what to do. The rules should apply. So yeah, that's where we're at, and be very happy to take questions by email or over WebEx, whatever we need to do. So thank you. Bye.